Example 4. Let's read this together. A large number of students in a college have completed a geography project. Now we talk about the statistic here that we're interested in is the number of hours to complete the project. Quite guided, this question. So you want to talk about this entire population. And now your sample is here. Is the population. Correct? And population n equals to 150 with test. Okay, you sample 150 students, you realize that you take the sum of all the hours is 4626, sum of the square of all the hours is 147691. Find the unbiased estimate. This one, if you forget, can you refer to C stats 6 last part? Okay, you forgot what is this all about. I think most of us can remember. Can remember, right? How do we find unbiased estimate of the population mean? Quite easy, right? You can use the data here to estimate unbiased, to estimate the population mean. You take 4626, divide by 150. Okay? We take 4626, divide by 150. There you go, answer. All right? You get 4626 divided by 150, which you get 30.8. This is also known as the sample mean. Correct? The observed value of the sample mean. Follow? Observed value of the sample mean. What about this unbiased estimate of the population variance? This is not sample variance. We are interested to use, one more time again, we are interested in to use this limited info we have out of 150 points. We're going to estimate the entire population's variance. So we use S squared. Am I a bit lost? Yes. Wow. Okay. Faster. Okay. See, maybe kanchong See. I know, because you all say I also. Then my computer angry. See, really? Hey, it has a soul, it has a heart. Amazing. Okay, carry. Okay, like that. Hey, like that. Okay. Okay. This is the, no need to memorize this, Ken. This is available in MF15, okay? This is available in MF15. Alright, no need to memorize. Okay, just dump in the values you have done. Alright? Just take note, your intermediate steps, just be careful, but just retain the 5 SF because you're going to use this later on. Is that right? Is that right? Then we can start our hypothesis. Okay, we can start our hypothesis. Alright, the question asks us to, can I have attention please, thank you. Test at a 5% level of significance whether the population mean exceeds 30 hours. So very simple. Again, this is step 1, define. Step 2, H1, H0, H1. Your mean is equals to 30. Your mean greater than 30. That's what you want to test. Level of significance 5%. Okay, again, when H0 is true, I would suggest that we just dump the values in. this is the case we talk about. The population variance is unknown. Okay? Unknown. But because n is large, n is 150, s square, s is a very good estimate for the population variance, correct? Then we get this. We use s instead of sigma because we actually don't know what is sigma. Remember we calculated s earlier? That is unbiased estimate for the population variance. So we use that. S over n. This is just calculate, you just throw into your GC. Let's go through one more time, okay? Let's go through one more time. What do we need to put into our GC? Alright? Alright? You go to test. In this case, it's still a Z test. So far, we all do Z test. Alright? Alright. Then we go to step. Okay, let's be very clear what we want to put in, okay? Let's be very clear what we want to put in. Have attention, please. Thank you. Now, mu naught is the value that you want to check whether the mean is indeed 30 or not 30 or greater than 30. So this is the one that we want to put in. Sigma, okay, now all of us are some of us are very confused. Look here, you actually don't have to do the work for the GC. You are not going to key this whole thing into, you're not going to key in the sigma of your x bar. One more time. In here, maybe I just say it here. This sigma, you are just going to tell the GC what is the population standard deviation. Population. Because you're going to enter your n, the GC can help you calculate what is the standard deviation of x bar. So let the GC do the hard work. This is population standard deviation. So in the case that you don't know the population standard deviation, you use the unbiased estimate. So in this case, we do know the unbiased estimate, which is 33.726. Not 33.726. Oh no, square root, sorry. Square root 33.726. Thanks. Square root of 33.726. Easy calculate for you. Follow? You are not going to enter square root of 33.726 divided by 150. No. The calculator asks for the population standard deviation. X bar, the computed value is 30.84. Your n now, this is very important. Using these values, the GC will do the hard work. And you want to do a one-tail test, you realize that the GC can calculate this p-value very nicely for us. 0.0382. Follow? All follow? Very good. So you see, the GC help us calculate this. Okay, again I say, okay, now better write this down. This one, not necessary if GC can calculate P value, which is, if they can, see, you already know this one, then you can, in presentation, you jump from here to here. Follow what I'm saying? But, look up. Then you don't tell me I waste your printing money, okay? I want to explain this again. We must exactly know what does p-value mean. P-value, remember, the smaller the p-value, the more evidence we have against it. It's the rare event. So p-value is the probability of observing and a value as extreme as 30.84. This is after standardizing, this is a flat. Follow? Yes. So therefore, this p value is here, then da 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 da. Good. All okay. The conclusion, okay. So remember this one? Sorry, better label the 1, 2, 3, 4. I got carried away. This is level of significance. You test statistic, you compute, correct? Then you conclude. Remember what I said about level of significance? You always compare. You have a threshold level, threshold probability, decision-making threshold. If your p-value is less than your decision-making threshold, you reject that. Oh, actually not mechanical, right? Mechanical. Okay? Always conclude in the context of the problem, Ken. Okay, look up. The question has one more part that I want to emphasize a little bit. State any assumptions or approximations needed in order for the test to be valid. Thank you. Thank you. Without looking at the answer, do you all know? Yes, huh? First thing, by writing, can I have attention? Thank you. Look, by writing this, you are making use of central limit theorem. Because population, the distribution of the population X, distribution unknown, you don't know whether it's normal. You can only say X bar is normal, hence this standardized one is a standard normal only if n is large and you use central limit theorem. So first level is central limit theorem. Second level, thing, since you don't know the population variance, you use 33.726. That is an estimate. That is not the population. Follow? So there are two things. So one thing is central limit theorem. The second thing is S square is used in S approximation. Sorry, this is number 2. Ayo, cannot count. Follow? Okay. Never mind, I know. 1 minute talk to your friend. Then after I show you video.